और today होतं
Yeah, so anyway, we'll start the session. The remaining participants will join later. So, good evening to all the professors, faculty members, research scholars, and PhD scholars, and my dear students and graph
மாவட்டமும்
theory
பள்ளிகளுக்கு
enthusiasts.
அமோனியா வாயு விபத்தில் பலியானோர் எண்ணிக்கை 10ஆக உயர்வு. உயிரிழந்தவர்களில் 2 பேர் சிறார்கள் என கூறப்படுவது குறித்து
My dear participants, so please mute your mic. Okay, so otherwise, my team will remove the particular participants. Okay, so it's give me immense pleasure to warmly welcome each one of you to our day 3 of our national level online workshop on mastering graph theory with advanced computational tools. It is organized by Indian Mathematics Professors Association and Infinity Research and Development Institute. First and foremost, I would like to sincerely thank all the participants for their enthusiastic participation and active engagement throughout the first 2 days of this workshop. So, over the first 2 days, we have explored the foundation of graph theory and computational graph concepts. So, we learn how to construct a graph, how to visualize the graph, and little bit on operations and structures. So, and implement the import today will implement the important graph algorithms such as BFS, that is a breadth first search, and DFS, depth first search. And also we have the several algorithms like shortest path algorithm, Dijkstra algorithm, centrality measures, and community detections. Okay, so and it's like that we have several algorithms today we'll explore. And by end of this today's session, so participants will be able to transform a real world data set into a meaningful graph models, so the applied advanced graph algorithms, and interpret the network structures from the research perspective.
ಎಷ್ಟು ಬಿತ್ತು ನಿಂಬು
So we'll start the today's session. Is there any queries from the previous day? There is a day 2 session. Is there any queries?
No, sir.
Yeah.
Sir,
Yes, ma'am.
I tried that random graph, sir. Every time when
Okay.
we give the same number of vertices and edges, we get different graphs only, sir.
Yeah, yes, ma'am. Yes,
At
ma'am. That
each
is a
time. Yes, sir.
yeah.
Even if we do not change the number of vertices and number of edges, we are able to get some other graph.
Yes, ma'am. That is a
That's nice,
random.
sir.
That is
Sir.
the
Yes.
nature is random.
Random,
So
yes. Sir.
yeah,
Yeah.
obviously you
Okay.
get that way.
Yes.
Yeah.
Thank you, sir.
Thank you, ma'am.
Yes.
I hope is the screen is visible.
Yes, sir.
Okay, so today first we'll explore matrix related concepts. Then we slightly elevate to the algorithms. Okay, so this is a very important concept. Okay, so that we can spend 15 minutes time to cover the matrix related concepts. Then we elevate on the algorithms part. So in the matrix related concept, that is the very easiest way. So for example, we can plot the adjacency matrix, distance matrix. It's like that. Okay. So first we need to create a graph. Okay. So for example, I can create a graph with the help of the SciPy. Okay, so the SciPy is another one library. Okay, so just wait. Yeah, is the screen is visible?
Yes, sir.
Yeah. Okay, so here we need to import another one package, that is a library. Okay, so import SciPy. Okay, so this SciPy is um, package also which will be helpful to the scientific calculations. Okay, so for example, scientific related that is a computational part, so we can easily use this SciPy. Okay, so and also we can have a NumPy is also okay. So I can explain the later. Okay, so first we can use this NumPy. Okay, so with the help of this NumPy, easily we can create a matrix. Okay, so that we need these three packages. Okay, so we need these three packages for um, the today's matrix related concepts. Okay, so one is a network X. This is already we done. Okay, so this library we have worked on last 2 days. And one more is a NumPy. The NumPy is a numerical related concepts. Okay, so for example, matrix and numerical calculations. If we use anyway, okay, so we need these library. Okay, so on this one is already we had explored the matplotlib. Okay, so this library which will be helpful for visualization techniques. Okay, so with this, so we need to create a graph. Okay, so for example, here we can create a graph G. Okay, so my graph G, maybe we can create nx dot graph of. Okay, so just I can create an empty graph. Okay, so after that, so just we can add the nodes. Okay, so for example, here I can add the nodes from
Gnanasekar ਕੀ ਕਰਦਾ ਕੋਠਾ ਵਾਲਿਆਂ ਦਾ ਕੋਠਾ ਇਹਨਾਂ ਦਾ ਅੱਛਾ
dear participants, please.
ਤੂੰ ਕਿੰਨਾ ਕੁ ਕਰਨਾ ਜੋ ਮੈਂ ਕਿ ਗੱਡੀ ਤੇ ਕਿ ਫਿਰਦਾ ਹਨਾ ਰਹਿ
Okay, so this is for just we have created a graph. After that, we can add the edges. Okay, so this is for the edges we have. That is a g dot add nodes from. This is a edge. Sorry, this is a nodes we have. That is a 1, 2, 3, 4, 5. Okay, so after that, we need to add the edges. Okay, so just I can add the edges from the adjacency list. Okay, so this is my the adjacency list 1 comma 2 1 comma 3 2 comma 3 2 comma 4 and 3 comma 5. This is an adjacency list. Okay, so based on that I can construct a graph. Okay, so this is our constructed graph like a G. Okay, so this is our constructed graph G. Okay, so just we can visualize this. So this is our graph. Okay, so this is our graph. So in this graph, we need to construct an adjacency matrix. Okay, so first we can construct with then adjacency matrix. Okay, so first we can construct an adjacency matrix with the help of the inbuilt function. Okay, so just I can create an adjacency matrix, my dear participants. So please don't unmute your mic. So otherwise, I will my team, which will be remove the particular participants.
So what is NP in the code?
Ma'am, once again,
So what is NP in the code? Second line.
NP is nothing but here we can use this NumPy. The NumPy is one of the package, one of the library, which will be helpful to construct a matrix. Okay, so now we focus on the matrix related concepts. Okay, so that's why we can use this NumPy. Okay,
Okay,
so
sir.
just wait.
Thank you.
I can share this.
Sir, can
Okay,
you
so
please
this
expand your screen in full screen? It is actually
is this, ma'am.
no, it's okay. When you type, it will be it is actually down, so it's not visible when you type. Can you put it in full screen mode?
Okay, just wait. Screen. Now here we are using this.
Sorry to interrupt, sir. I think they're saying that when you type the command, the
Okay.
output window is not visible, I think. So I don't think you can do anything about it, like while writing
Is this
the
visible
command.
now? Is this okay?
And now it's visible.
Okay, ma'am. No. I think this is we have followed the Google Colab, but here we can have the view option in the slideshow manner. But this is a hands-on. Okay, so we can't. I don't know about how to expand the screen. Okay, so in the menu we can have this option. Okay, so just I can try this in the view. We can have so deep.
हेलो सर
Yeah, yes, ma'am.
सर और लेफ्ट लेफ्ट साइड है सर क्रॉस मार्क के no no sir
Almost
that
it's a
side
full screen.
this side sir this ask genuinely is there na sir
Is this okay?
okay sir.
Okay.
Sir, you can continue.
Okay, so just I have used this uh, Google Chrome. Okay, so that's why we don't have a full screen mode options. Okay, so this is our graph. So in this graph, we need to construct an adjacency matrix. Okay, so in this graph, we need to construct a adjacency matrix with the help of Python. Okay, so that is our aim. Okay, so that here we can create an adjacency matrix. Okay, so for example, we can give the name. Okay, so this is an adjacency matrix. Okay, so for example, here we can have one of the inbuilt function is there, that is a nx dot adjacency matrix. Okay, so adjacency matrix. Okay, so this is an inbuilt function we have. So with the help of this inbuilt function, so we need to use, we need to find the matrix. Okay, that is an adjacency matrix. Okay, so here we can use the algorithm. Okay, so here we can use the algorithm as a too dense. Okay, so this is one of the algorithm I can explain the later. Okay, so I can explain in the later. Okay, so this is an inbuilt function we have. Okay, so then we need to visualize the matrix. Okay, so now we can get the adjacency matrix, but now we need to visualize with the help of for loop. Okay, so that is a very important. Okay, so if you run this, okay, so just wait, if you run this, can collect the adjacency matrix, but we need to visualize this. Okay, so we need to visualize the entire matrix, then only this will be applicable. Okay, so that here we can use this for loop. Okay, so this is the just wait, I think, is there any typo?
ഒരു കുഴപ്പമില്ല, ഞങ്ങൾ ബ്ലഡ് കൊടുത്ത് ഫുഡ് കഴിച്ച് പതുക്കെ റെസ്റ്റ് എടുക്കാം. ഒരു കുഴപ്പമില്ല, ഞാൻ ദൂരെ മാറിയിരുന്നോളാം. അഥവാ ഇനിയിപ്പോ കണ്ടുവന്ന് രണ്ട് ഇടി ഇരിക്കും.
Think we can have an error.
Sir, dense spelling is correct.
Yes, thank you, ma'am. Okay, so here we can have this typo. Okay, so now we can execute this. You can see, so this is an adjacency matrix. Okay, so this which will be helpful for the print the matrix in the form of the matrix format. Okay, so here you can see this print, this means that, so here we can this is an adjacency matrix, is a title. Here we have printed. Okay, so in the first row I want to print the nodes. Okay, that is a labels. Okay, so for example, the label equal to just list of g dot nodes. That means that we need to visualize the nodes in the headers. Okay, so headers and the first columns. Okay, so that easily we can understand. Okay, so then here we can print the labels of the nodes. It's in the row and column wise. Okay, so that's so we can use this for loop to print the matrix. Okay, so here you can see, we can compare with the previous graph. Okay, so we can compare with this previous graph. Here we can have a 1, 2, we can have an edge. Okay, so for example, yes,
Sir, can you type the code in the chat box, sir, please?
sure, ma'am, sure. Just wait. I can explain and I will share. Okay, so here you can see the 1, 1, there is no loop. This is a simple graph. There is no loops are there. That's why 1, 1, it's a 0. Okay, so this is a, if the adjacencies exist. Okay, so we can get the 1. Okay, so if the adjacencies not there, then we can put the 0. That is our definition in the literature. So it's like that. The 1, 2, so we can have an edge. Okay, so this is 1, 2, we can have an edge, so that we can have a 1. And also 1, 3, we can have an edge. So that we can have a 1. And also 1, 4, we can have an edge. So that we can have a 1. And also 1, 5, we can have an edge. So that we can have a 1. And also 1, 6, we can have an edge. So that we can have a 1. And also 1, 7, we can have an edge. So that we can have a 1. And also 1, 8, we can have an edge. So that we can have a 1. And also 1, 9, we can have an edge. So that we can have a 1. And also 1, 10, we can have an edge. So that we can have a 1. And also 1, 11, we can have an edge. So that we can have a 1. And also 1, 12, we can have an edge. So that we can have a 1. And also 1, 13, we can have an edge. So that we can have a 1. And also 1, 14, we can have an edge. So that we can have a 1. And also 1, 15, we can have an edge. So that we can have a 1. And also 1, 16, we can have an edge. So that we can have a 1. And also 1, 17, we can have an edge. So that we can have a 1. And also 1, 18, we can have an Okay, so that is an adjacency is exists. Okay, so that we can get 1. The remainings are 0. Okay, so for example, 1 comma 5 it's not an adjacent, and 1 comma 4 is not an adjacent. Okay, so like that easily we can print the entire matrix. Okay, so this is only an example. Okay, so you can use it in any graphs. Okay, so you can use any type of a graph. Okay, so this is only an example. Okay, so just check this. Is this clear? Is there any queries from the participant side? So the two dense is one of the algorithm. Okay, so I can explain the later. Okay, so in the BFS and DFS, I can explain. Okay, so that is the next part.
Sir, for this output, we will not get the graph.
And the previously we have got the graph, ma'am. Okay, suppose if you
No,
want the
particular
single,
for this program and this output, we will not get the a graph.
for example, if you need a graph, you can just
That
we can
adjacency
visualize this.
matrix with the graph. How to get the output as a graph of this program?
Yeah, just wait. Okay, so you need to incorporate this nx dot draw of network x of g, and this is a bld dot show. Okay, so just you can execute this. The graph with um, matrix is also there. Okay, so this is a graph with adjacency matrix. Is this, ma'am? Is this your query?
Sir, now it's clear. Thank you. Thank you, sir.
Yeah, just we need to visualize with the help of the inbuilt function. Sivaragavi, ma'am, is there any queries on this? And is there any a particular part, or need to explain the entire code? Sivaragavi? Yeah. Okay, so I can explain once again. Okay, so I think there is no doubts on this. Okay, so this is already we had done in the almost the last 2 days. Okay, so how to create a graph in Python. Okay, so that's so we have created a graph. Okay, so this is a nodes we have, that is 1 2 3 4 5, and this is an adjacency list we have. Okay, so 1 2 1 3 2 3 2 4 2 3 5. So these are all the adjacency list. Okay, so after that, so we have visualized the graph. Okay, so this is our graph, and after that we need to get the adjacency matrix of this particular graph. Okay, so that have used this adjacency matrix. Okay, so for example, this is an inbuilt function where we have adjacency underscore matrix of g. Okay, so this is a inbuilt function. So with the help of this inbuilt function, easily we can create adjacency matrix. Okay, so this two dense is nothing but, okay, so this is a DFS algorithm, that is a depth first search algorithm part. Okay, so I can explain the later. Okay, so in the after the session we have covering the all the algorithm concepts. Okay, so I can explain there. Okay, so the two dense. Okay, that means that that will search with the DFS, that is a depth first search algorithm. Okay, so that's why we can use this two dense. And after that, I want this title. Okay, so here you can see, so this title is there, that is a print adjacency matrix. See, okay, so we can use the a print function to print the adjacency, list. Okay, so and after that, so we need to create this label. Okay, so for example, here you can see the nodes labels are there. There is a 1 2 3 4 5, and columns also 1 2 3 4 5. We need to create. Okay, so that I can use this labels. Okay, so label is nothing but the list of nodes. Okay, so here you can see the list of nodes we have represented. Okay, so if you want to print like this, we need to use this for loop. Okay, so this is for the first row. Okay, the first row there is no issue. Okay, so for example, I need this empty space. Okay, you can see here we can have a one empty space is there. So that's why I can give one empty space, and after that we can give an in end of the stage I can give us one empty space. Okay, so that's so here we can use this print function. Okay, so the next one here you can see this column labels are there. So that's why we can use this for loop to print the column label. Okay. So for the label in the labels, so print the labels to end. Okay. So the next we need to print this entire matrix. Okay. This is an entire matrix. We need to print. Okay. So for I in the range of the length of the adjacency matrix. Okay. So just we can use the print labels I in the adjacency matrix of I. Okay. So this I is collected from the adjacency list. Okay. So if the adjacency exists, we can that assign as a one. If the adjacency is not exist, that can assign as a zero. Okay. So that's how we can plot the entire matrix. Is this clear, ma'am? Sivaragavi, ma'am? What end will do inside?
Sir, I'm getting error for this program. The error is the SciPy is not named.
Yeah. Okay, ma'am. So
That is the
you need
error.
to, yeah, you need to mention the NumPy. Okay, so please, here we didn't use any SciPy. Okay, so here we can use it as a NumPy. Okay, so that is a numerical Python. Okay, so we need to use that NumPy. Okay, so you need to give this. Okay, so you need to give this library. Okay, so you need to import this library, then you can get the output. Just check
Sir, I
this.
added that code, but it is showing that it is a SciPy only. It is showing not NumPy.
I
What's the
think
problem?
you have any.
I added
Uh,
that nothing. I copied paste as you have shared in the chat box.
can you check
I have
the
not edited
previous
anything.
previous cell? You mentioned any SciPy. There is no issue. Suppose if you face any error, just here you can add one more line. Okay, so there is a SciPy. Okay, so just you can add this. Okay, so then that maybe error will rectify. You can add this line, the SciPy. This is another one library. Yeah, nomini sysodia. Here we focus only in the graph theoretical concepts. Okay, so that if we cover the serial matrix,
I
that
got,
isn't
sir.
out of
Thank you,
box.
sir.
Yeah, yeah. Shall we move? Is there any queries from the participant side? Okay, so this is our this is our graph. This is an adjacency matrix. Okay, so then um, we move on to the distance matrix. Okay, suppose if you want to calculate the distance matrix. Okay, so here also, we can use an algorithm. Okay, so the distance matrix here we can use the Floyd Virtual NumPy. Okay, so that is one of the algorithm. So based on this algorithm, we can check the matrix. Okay, so this is the code we have the same matrix. Okay, so we can visualize the mm, distance matrix. Okay, so in the same matrix, just we can use this. Okay, so for example, we can use this distance matrix. Okay, so just you can give any name. Okay, so for the understanding purpose, I can give this distance matrix. Okay, so in this distance matrix, just we can use it as a NP. Okay, so the NP is nothing but that is a numpy. Okay, so NP is nothing but that is a numpy. Okay, so here we can use this array format. Okay, so here we need to use this NX dot with the help of this Floyd Warshall. Okay, so this Floyd Warshall is one of the algorithm. I can explain the later. Okay, so that is a Floyd Warshall. Okay, so the Floyd Warshall. Okay, so this is a keyword. Okay, so I want to calculate for the graph G. Okay, so I want to calculate for the graph G. Okay, so then you can you can use the print function. Okay, so with the help of this print function, you can give the title. Okay, so the title maybe we can use it as a distance matrix. Okay, so then you can sorry. Okay, so then we can print the entire matrix. Okay, so just I can copy this. Just I can copy and paste here. Okay, so this is for the distance matrix. Okay, so for example, the 0 to 0, there is no distance. Okay, so that is the next one, 0 to 1. Okay, so here we don't have a label. Okay, suppose if you know, if you need the labels, so we need to use that for loop. Okay, so for example, the previous one here we fix the for loop. No, okay, so just we need to use this. Just I can copy this and here we can paste. Okay, just you can execute this. Oh, sorry. Here the label is mismatched. Okay, so like this we can get the labels. Okay, so for example, so the 1 to 1 the distance is 0 and the 1 to 2 the distance is 1. Okay, so the 1 to 2 the distance is 1. Okay, so just wait, I can plot the graph here. Okay, so let's start. Okay, so this is our graph. Okay, so this is our graph. We can see the 1 comma 1, the distance is 0. Okay, that's why we can have that 0. The 1 comma 2, we can have the distances of 1. And 1 comma 3, we can have the distances of 1. And 1 comma 4, the distance is 2. The 1 comma 5, the distance is 2. It's like that. Okay, so here we can have the 2 comma 1, 2 comma 1, the distance is 1. The 2 comma 2, the distance is 0. And the 2 comma 3, the distance is 1. And the 2 comma 4, the distance is 1. And the 2 comma 5, the distance is 2. Okay, so it's like that. Easily we can create the distance matrix of the given graph. Okay, so just wait, you can share this.
So why is that dot coming after his point?
Yeah, here we didn't specify that it's a integer or float. Okay, so that's why defaultly choose the distance as a decimal.
Hello, sir.
Yeah, yes, ma'am.
Can you please explain the first code of this program? Distance
First,
matrix is equal to
yeah,
only that code I want.
this one, this one.
Yes, yes, yes.
Okay, so the distance matrix is nothing but you can put any names. Okay, so for example, you can put the DM. So DM. Okay, so the DM stands for distance matrix. That is your wish that you can put anything, but here we need to use this np dot array. That np dot array is nothing but the previous one. We can assign the matrix. Okay, so it's like the previous one. I can compare this easily. You can understand. Okay, so here we have used the for loop. Okay, so for loop to print the matrix. Okay, so print this type of matrix. But here we didn't use this for loop, directly use the inbuilt function. Okay, so that is a np dot array. Okay, so the np dot array, which will be useful to create a matrix. Okay, so that's why I can call this np dot array here. Is this clear, ma'am?
Just that what fluid or shall what that
Yeah, this is for the distance matrix algorithm.
has.
This is for the distance. If you want to find out the distance matrix, we need to use this algorithm. Okay, so this is one of the algorithm in our literature. Just we can use this algorithm to find the distance matrix.
If it is not there, then it will not work.
We have a certain algorithms are there. Okay, so if you want, this is one of the easiest algorithm to finding the distance. That's why we can use this.
Okay, sir.
Also, sir, why the matrix is not coming as a single matrix? Each row is separate. No?
Yeah.
It is not in a single matrix form. Bracket is not a single enlarged one.
In Python, it's always shows like that, ma'am.
Okay.
In the Python output. This is not exactly as a matrix in Python. This is a list. Is this clear? Shall we move? Yeah, is there any queries from the participant side? Okay, so as we cover the adjacency matrix, and also if you want to cover the incident matrix, okay, so that is very similar. We can script it. Okay, so there is instead of adjacency, just we can change it as incidents. Okay, so then the degree. Okay, so for example, here we can assign the degree of matrix. Okay, so it's like okay, so it's like we need, if you want to get the this is all I think we done the previously. Okay, so just so wait.
Sir, I am getting as indentation error, sir. What is that, sir?
The indentation error is nothing but, sir. Okay, so you need to give the exact space. Okay, so if you use the for loops, okay, so you need to give in the exact. Okay, so for example, here
Yes, sir.
I can see this print. Okay, so
Mhm.
you need to give this much space.
Okay, okay, okay.
Yeah, that is an indentation.
Okay, thank you.
Okay, so this is for the degree matrix. Okay, so for example, the degree matrix is always a diagonal matrix. Okay. So for example, here the degree of 1 is 2, and the degree of 2 is 3, and degree of 3 is 3, and degree of 4 is 1, and degree of 5 is 1. Okay. So this is called a degree of a matrix. That's a degree value. It's a diagonal matrix we can attain. Okay, so in the similar way, easily we can create the Laplacian of a given matrix. Okay, so this is for the Laplacian value of the given matrix. Okay, so instead of the adjacency, so we need to change it as a Laplacian. Okay, just wait, I can explain that also. Okay, so for example, I can put the L. Okay, so L is nothing but my Laplacian matrix. Okay, so next dot. Yeah. Okay, so this is for the Laplacian matrix of G. Okay, so my dear participants, so please mute your mic. Okay, so that will be very helpful for. Okay, so then we can use this two tens. Okay, so then we can print the L. Okay, so this is for the Laplacian of the given matrix. This is the Laplacian value of the given matrix. That is a graph.
Sir, can you please explain the output of both programs? Output.
Degree and Laplace. The degree is nothing but, ma'am. Okay, so just I can visualize the graph here. Okay, so you can easily understand. Okay, so this is our graph. Okay, so here you can see the first vertex is in the bottom. Okay, so the first vertex, the degree is 2. Okay, so in the first vertex, the degree is 2. That's why in the degree of degree matrix, we can have this 2. Okay, so here you can see the second vertex. Okay, the remaining everything is 0. The remaining everything is 0, the first column. So first row, and the second value, that is a first, that is a 2 comma 1 is, that's not possible. So that here the second vertex degree is 3. Okay, so that's why we can have this 3. Similarly, the third vertex, the degree is 3, and the fourth vertex, the degree is 1, fifth vertex, degree is 1. Okay, so it's like that. We can attain the degree of a matrix. Okay, so then we have a Laplacian. Okay, so in our literature, we can have the Laplacian matrix. Okay, so here we have construct the Laplacian value for the given graph. Okay, so that's how we can plot this graph. Okay, so for example, the 1 comma 1, the Laplacian value is 2. The 1 comma 2, the Laplacian value is minus 1. And the 1 comma 3, the Laplacian value is minus 1. Remaining is 0. Okay, so it's like that. This which will be helpful for the energy related concepts. So suppose if somebody working on the energy concept. Okay, so that might be useful for this context.
Thank you, sir.
Yeah. Okay, so then we move on to which is similar for the normalized Laplacian matrix. Okay, that is also possible with the normalized value. Okay, so for example, if you want to round off with some other normalization, we can, that is possible. Okay. Also the reachability matrix also there. Okay. The reachability is this. So that's how in the matrix part. Okay. So next we'll move on to algorithms. Okay. Is there any queries from the matrix related concepts?
Hello, sir.
Yes, ma'am.
Not a query, but I just want to know, is there any inbuilt function like Laplacian matrix or distance matrix to obtain the Seidel matrix also?
Yeah, we have one. We have the Seidel matrix. We can have an inbuilt function. Okay, so that is also very easy. Okay, so just I can explain that. Okay, so that also I can explain. Please.
Yes, thank you.
So due to the time constraint, I skip that. Okay, so I can explain. I can
No, sir,
explain.
no, just I want to know that is there any inbuilt function in this or
Yeah,
not?
we can have an inbuilt function.
Okay, sir. Okay, yes, fine.
Yeah,
Thank you.
yeah. Shall we move? Is there any other queries?
Sir, excuse me, sir.
Yeah, yes, ma'am.
Sorry, in the matrix, there is a dot displayed, no, sir?
Yeah.
What does that dot mean, sir?
Ma'am, here we have work on the convert a graph to a value. Okay,
Okay,
so
sir.
that's why Python defaultly choose it as a floating value. Okay, suppose if you want to convert it as an integer, that is possible. Okay, so that is possible to convert an integer value. Okay, so but defaultly choose it as a uh, float. Okay, so this is for the Seidel matrix. So this is a code for the Seidel. Okay, so this is for the Seidel. Okay, so here we can use this nx dot numpy of array. That is a type. Okay, so just we can calculate the length of the a. Okay, so then we can use the ones. This is a formula we can have. So just we can apply the direct formula here. Okay, so the ones of n comma n and that eigenvalues into 2 into e. Okay, so just directly we can apply this to find these Seidel values. These are all the Seidel of a given matrix, given graph. Shall we move? Yeah, if there is no queries, so we'll move on to the next part. Okay. That is a seedal concept. Okay, so for example, the given graph seedal matrix. Okay,
Excuse me.
so yeah, yes, ma'am.
For the last program, I drawn the graph here in
Okay,
my laptop.
okay,
So actually, I'm not understanding that 0 -1 -1. Can you just explain that one program?
sure, ma'am. Sure, sure.
Not program, output.
Hmm. Yeah. Okay, so here first we need to understand the seedal concept. Okay, so I think yeah, I have aware about that. Okay, so in the serial, we can use the diagonal values as a 0. If -1, it means that an adjacent. Okay, so the plus 1, that means that it's a non-adjacent. Okay, so with the help of this, so we can apply in the serial concept. Okay, so here it's like that. Okay, so just wait. I can print the graph also. Okay, so this is our graph. So in this graph, okay, so if the first one, there is no the serial values. That's why we can have this diagonal. The diagonal, all the diagonal values are 0. Okay. So in the -1, it means that the 1 comma 2, the 1 comma 2, we can have an edge. That's an adjacency. So that's why we can have a -1. Okay. So and also 1 comma 3, we can have an adjacency. That's why placed as a -1. Okay. So that is the value we have mapped here. Okay, so just we can apply this formula. So n is nothing but the length of A. Okay, so the length is here the 5. Okay, so here this is a formula which will be applied for the serial. That is a ones of a matrix minus that particular eigenvalues minus 2 into A. Okay, the given matrix size, the 2 into A. Okay, so with the help of this, we can attain the concept. Okay, this is a large part. Okay, so here I have provided an end of the code. Okay, so that's why it's little bit difficult to understand. That is a huge topic.
Understood, sir. Thank you, sir.
Yeah. Okay, so next we'll move on to the algorithm part. Okay, so we can take one real-time data. Okay, so with the help of the real-time data, we can check the remaining algorithms part. Okay, so for example, I can use, I have a one data. Okay, so with 1,000 nodes. Okay, so just I can apply this data and okay, so dear participants, this is little bit advanced level. Okay, so as of now, here we followed as a very basic level. Okay, so now we elevate from that advanced one. Okay, so here we can apply the real-time data set and we can apply the entire concepts which we have followed on the before the last 2 days. Okay, so now we need to import a particular data set. Okay, so just here. Okay, so here we need to import the data set. Okay, so the data set import is very simple. Okay, so go to this. Is this visible, ma'am? Dear technical team, is this visible?
Yes, sir.
Yeah.
Yes, sir.
Okay, so just go to this file menu. So in this file, you need to upload the file with the drive, or you can click this upload option is there. Okay, so just click this upload button. Okay, this will be navigated to the data set. Okay, so just I have one data. Okay, so this is a data. Just open this data. Okay, so this is my data I have uploaded. Okay, suppose can I share it in the I think it's not possible. Can I share this in the WhatsApp group, the data set? Okay, so I have shared this data set in the WhatsApp group. Okay, so if possible, you can also do the hands-on with my team. Yeah, have sent the data set in the WhatsApp group. Okay, so just you can also import the data set here. Okay, so just type, just click this upload option. Okay, so that will be available in the file menu. Okay, so you can the file you can choose the data set. Okay, you can upload. Okay, so this is a step one. Is this clear? Okay, so this is a very important. So otherwise, you didn't get the output for the following uh, codes.
Sir, once again, just you explain,
Yeah.
sir. Here we are not getting file where to upload.
Yeah, yes, sir. Just click this file menu on the left side. Go to this here. We can have the search options as there, the inbuilt option, the code snippet, the focus mode, and the key, and it's like that. Just click this files.
Okay. Okay.
Is this visible?
Yeah.
Just
Yeah. Yeah.
select this file. Just select this file. This will
Okay.
open this type of window. So in
Mm,
this window, you can have an upload option. This first menu, the
okay.
upload to session storage. Okay, so just click this. This will open to your storage. So in the storage, you can upload the particular data set.
Okay.
Okay,
Thank
so
you.
this is our data set. Okay, so this data set contains around 1,000 nodes, I think so. Okay, so then just I can close this. Is this clear? Is there any queries from the participant side? You have to save it
No,
on the
sir.
laptop.
Yeah, clear.
Yeah, yes, ma'am. You need to download the data file. Okay, so after the download, you can upload the data. Okay, so just I can open this new code. So here, so we need to use the one more library. Okay, that is a Panda. Okay, so the Panda, which will be helpful to upload any data set in the Excel or CSV format. That may be anything. Okay, so if you want to upload the data set, so we need to use this Panda. Okay, so just we can import that. Okay, suppose if you are not yet installed, okay, so just install the Panda. Okay, so many of the participants are newly joined. Okay, so just pip install Pandas. Okay, so just I have installed the Panda. Okay, so this is already have installed. That's why we can have this requirement is already satisfied. Okay, suppose if you are not yet installed, so please execute this code because this will be helpful to install the pandas in your notebook. Okay, so please after completion, so please give a thumbs up. After the Panda installation, so we need to import this Panda. Okay, so just I can import the Panda as PD. Okay, so here onwards, the panda, which will be called as a PD. Okay, so the PD stands for the pandas. Okay, so then we can import, this is already we have import. Okay, so for example, here also we can import once again. Okay, so this is for the network package. Okay, so we need these two packages, which will be helpful for doing following codes. Okay, just wait. So then, so we need to import that particular file. Okay, so with the help of the PD read Excel. Okay, so we need to this data set which are available in the Excel format. Okay, so the data files are in the Excel format. So we need to read the Excel file first. Okay, so that here we need to use the pd.read Excel. Okay, so the pd.read Excel. Okay, so just here we can use the DF. The DF is nothing but that is a data file. Okay, so DF is nothing but that is a data file. Okay, so just we can use the PD. The PD stands for the pandas. So then I want to read the Excel. Okay, so just I want to read the Excel. Okay, so just I can use this inbuilt function. After that, you need to specify the function, the file name. Okay, so what is the file name here? Okay, so just click this, just click as a copy as a path, copy path. Okay, so just copy this path and here you can provide this. Okay, so this is the path we have. Sorry. Okay, so
Please repeat the question of copy path.
yeah. Okay, so just click this file, go to, this is our file name. That is a network underscore science thousands like that. Just you can see this three dotted button. Okay, so just click this. You can have this much option: download, rename file, delete file. Okay, so we need to copy the path file. Okay, so just copy the path and you can paste it here. Is this clear, ma'am?
Yes, sir.
Yeah. After that, in the file have the different sheets. Okay, so here we need to specify the sheet name. Okay, so we that file have the multiple sheets. Okay, so here we need to specify the sheet name. Okay, so sheet name we can use, we can have the sheet name that's I think edges. Okay, so edges underscore 5652. I think this is a sheet name. Okay, so we need to open this. Okay, so then, so we need to get the edge list. Okay, so due to the typing, just I can copy and paste it here. Okay, so this is for the g is equal to nx dot from the pandas edge list. Okay, so just we can use this inbuilt function from the pandas to edge list. Okay, so just we can collect the edge list. Okay, so here we can use the source, target, and weight. Okay, so in the previously we have used the weighted graph with the help of the 3 coordinates. Okay, so the yeah, that file is available in the WhatsApp group. So please check it. Okay. So then we need to print the number of nodes here. Okay. So number of nodes and number of edges. Okay. So
Maybe,
just you can
sir.
execute this.
So we can use anything as a sheet name.
Yeah, that is available in the WhatsApp group. I think so.
Sir, can you paste the code on the chat, please? Because I am getting a syntax error.
Yeah, just wait. Yeah, I have pasted.
सर व्हाट्सएप में दिया हुआ नहीं है, डाउनलोड हो रहा है मेरे में।
Yeah, you just wait. I think I have posted in the WhatsApp group. So in the WhatsApp group, you can have this file. Okay, so just download the file. You need to upload that particular file into uh, this uh, Google Colab.
सर डाउनलोड नहीं हो रहा।
Sir, I didn't understand.
Sir, still now not received any file, sir, in your WhatsApp group.
Just wait. We have shared in the WhatsApp group. Mastering graph theory, that is the WhatsApp group. Which you already shared in the Excel file. Just check this. That is a network underscore
Yes, sir,
science.
we got, sir.
Yeah, you need to download that file. Okay, so after download the file, you need to import from this Google Colab.
Okay, sir.
Is this clear?
Yeah,
सर
yeah.
हाउ टू इंपोर्ट?
Yeah, that is very simple. You can have this file menu on the left of the window. Just click this. You can have this import option. Just you can have click this. That file which are available in the downloads, maybe in your PC. Okay, so just you can select the file and you can upload it.
ओके सर।
Yeah. So here we have directly import the file. So that's why there is no need to specify the path. Directly we can give this file name. So totally in this file have the number of nodes are 1200 nodes are there. Okay, so here you can see 1200 nodes are there, and totally we can have the 5652 edges. Okay, so that is a 5652 edges are there. This is a large set of data.
सर फाइल डाउनलोड किए फिर भी नहीं मिले। हाँ
Sir, I don't know Hindi actually. Sorry. So please post in the chat box. I can understand. Yeah, our WhatsApp group. That is a mastering graph theory with advanced tools.
Sir, may I guide him?
Yeah, sure, sir.
हिमांशु, आपने लैपटॉप में डाउनलोड किया है? राइट क्लिक करके?
यस सर।
तो लैपटॉप में जहां डाउनलोड हुआ है, यहाँ पे अपलोड पे जाके वो सिलेक्ट करना है। गूगल कोलैब में अपलोड पे जाके वो रिसेंट में जाके देख लो या डाउनलोड्स में जाके देख लो। ये नेटवर्क साइंस 1000 ये मिल जाएगा आपको। एक बार ट्राई कर लो।
नहीं मिले हम। हमने
अच्छा, नहीं
फाइल
मिल रहा?
ओपन किए ना, उसके बाद पता नहीं चला कि किस पर चेक करें।
अच्छा, एक बार दोबारा
एप्स
डाउनलोड कर लो।
डेस्कटॉप।
नहीं, डाउनलोड्स में जाए। या तो जब आप डाउनलोड कर रहे हो ना, तो लोकेशन सिलेक्ट कर लो कि इस लोकेशन पे मैं सेव कर रहा हूँ उस डाउनलोड को।
लिखा है कि नेटवर्क साइंस 1000 नोट्स
हाँ, ये
ऑलरेडी
आ रहा
एग्जिस्ट,
है।
डू नॉट रिप्लेस इट।
अच्छा, आप रिप्लेस करके और फिर एक बार डाल दो, कोई बात नहीं, फिर अपलोड करने की कोशिश करो।
Yeah, sure. Dhanalakshmi ma'am, I can accept the request. Okay, so
ऐसा नहीं हो पा रहा है।
yeah, I have approved Dhanalakshmi ma'am.
तो हिमांशु, आप एक बार बाद में ट्राई कर लेना, कोई बात नहीं। आराम से मिल जाएगा, इजी ही है।
Okay, sir.
Sir, I'm not getting the output here.
Yeah, is there any error, ma'am? So kindly post in the chat box. I can understand. I can check that.
Nothing, no such file or directory, network science 1000 node, like I got this error. No such file or directory.
Yeah, kindly check in the left side. Okay, so left side you can have this window. So in this window contain this file, that network underscore science. Check the window. Is the file is available, ma'am?
I have downloaded twice, so it is file 1. It is showing like pack.
Yeah,
Pack
if the
1.
file one, just we
Yeah.
need to change it as a file here. For example, in the XLX. Okay, so just add the exact file name. Okay, so just you can check this. Okay, so just copy path. Okay, so we can have this one, this. Okay, so in this you need to add the one or something. Okay, so for example, if contain like this, you need to add it exact file name. Is this clear? Now we can
Yeah.
check it.
I got here notebooks slash network. Whenever I
Yeah. Okay,
copy
so
the
just
path, I will get notebooks. I'm doing in Jupyter.
oh, so if it is a Jupyter,
Yes, sir,
you can
Jupyter. Whenever
directly,
I copy path, I'm getting actually content bar Jupyter. Sorry, notebooks.
yeah, that is a separate process in the Jupyter notebook now. So in the
Okay.
Google Colab, we can directly import here and you can access the data. But in the Jupyter notebook, that is in the offline, you can store in the particular file and you can copy path and you can execute there. Okay, so I will explain in end of the session, ma'am. Okay, so you can listen that. Okay, so surely I will explain the later.
Okay, sir. Okay.
Yeah. Shall we proceed? Dear participants, shall we
Yes, sir.
proceed? Yeah.
Sir, WhatsApp group is my name is not included in the WhatsApp group, sir. I am not getting that file.
Yeah, sir, kindly check your registered email ID. Our team, which have shared the WhatsApp group link and as well as a meeting link. Kindly check it. Okay, so
Meeting.
yeah, the
Okay.
same emails, the
Yeah,
same
yeah.
email
Okay.
communication, we
Okay.
can have
Thank you.
this WhatsApp group. Okay, so in this data, which we have, I think I have shared this code. Okay, so in this data set that have 1200 nodes and as well as 5652 edges. Okay, so this is a actually little bit large data. Okay, so which we work on this large data, we can apply the entire concepts here. Okay, so the next one, we need to check the remaining concepts. Okay, so for example, we need to check the degree. Okay, so we need what are all the degrees are there. Okay, so and the neighbors, for example, if you want to found the particular vertex neighbors, that is also possible here. Okay. Okay, so first we need to visualize the graph. Okay, so first we need to visualize around 50 nodes. Okay, that make you a given clear cut idea for the beginners. Okay, so just right, I can I can visualize the first 50 nodes. Okay, so for example, just we can use the sample nodes. Okay, um, uh, just wait. Okay, I can create. I can close this. Okay, so just I can choose the sample. Okay, so sample data from this. Okay, so that I can add the sample nodes. Okay, so in the sample nodes, just I can use this list. Okay, so list from my g dot nodes. Okay, so g dot nodes is nothing but, okay, so in the graph, just we can collect the g dot nodes. Okay, so in this G dot nodes, so we need to use the first 50 elements. Okay, so first we need to the range first 50. Okay, so just we can give a space the 50. This means that I need to select the 50 samples from the data we need to visualize. Is this clear? This particular line. So the data contain the 1200 nodes. We can't possible to visualize the 1200 nodes in the single output window, so that I can choose randomly in the 50 nodes. Okay, so that is it's not randomly. We need to select the first 50 nodes. Okay, so that's why we can use this range. That is a range of 50. Is this clear? Okay, so then we need to visualize the graph. Okay, so we need to already we had seen the subgraph concept, I think in the yesterday or day before. Okay, so just we can use the H. Okay, so H equal to, okay, so we need to implement that subgraph. Okay, so G dot subgraph. Okay, subgraph of G. Okay, so here G is nothing but G is a sample graph, so just we can choose it as a sample underscore graph. Is this clear? So just we can get the subgraph from the data. After that, so we need to visualize the figure. Okay, so we can use this PLT. The PLT stands for the matplotlib, so that is already we are done. Okay, so PLT, we need to fix the size. Okay, so in the previous one, the figure size is too low, but we can't visualize entire 50 nodes, so that I want to increase the plot size. Okay, so that we can increase the figure size. Okay, so figure size. Okay, so figure, fig size. So this is an inbuilt function. We can give the figure size like just I can choose the 10,8. Okay, so defaultly they can choose this as a 10,8. Okay, so this is a figure size. Sorry. Dear participants, so please mute your mic. Okay, so that will be helpful for. Okay, it's not a sample graph. Okay, so it's a sample nodes. Okay, so that's why we can have an error. Okay, so this is for the sample nodes. Is this clear for these three lines? Ubender Reddy Ganga, I will add it in the later. Okay, so in the end of the session, I can add. Okay, so is there any queries on these three lines? So the first one, just collect the 50 sample nodes. Based on the sample node, just we have created the subgraph, and then we can create the figure size. Okay, so then we need to draw. Okay, so that this is already we have done. How can we draw the graph? Okay, so just we can use this nx dot draw network x. This is a graph name, and this is a node size, and the node color, and the font size. Okay, so then sorry, so we need to plot the graph. Okay, so plot title axis like that. Okay, so that's we have done. Okay, so just you can execute this. You can see. Okay, so this is the data we have. Okay, so this is a graph. This is a sample of the 50 nodes in the data file. Okay, so this is actually, it's a disconnected graph that we collected from the 50 nodes. Just we have selected the 50 nodes and plot the graph. Okay, so if possible, we can decrease the size. Okay, so if we decrease the size, that may be visualized. So this is a graph we have.
So
Okay,
this
so
is
this
from the
is
data set that you have uploaded, and for that,
yes,
this is
ma'am. Based on the data set, just we have selected the first 50 data, that is a sample data. So based on the data, we can visualize this graph. Is this clear? Shall we move?
Sir, what is mean by that 10,8?
That is a figure size. Here, you can see that, you can notice that.
How it
So
works?
this figure size is increased. Okay, so
Yes.
if you compare with the previous output window, you can see the smaller one. Now the figure size window is increased. Is this clear? Shall we move?
I got different outputs, sir. So
Yeah, defaultly that change the output, ma'am. We can't get the exact output. The Python, that is a random output. Okay, so maybe our vertex at that assign the different location.
sure, sir.
Shall we move?
Yes, sir.
Yeah. So the next we'll check the degree. Okay, so that is a high degree nodes. Okay, so uh, what yes, a particular degree have a highest a particular node have a highest degree. Okay, so that is called it as a high degree node. Okay, suppose if it is a, if you are doing a social media analytics, so on the time, so this plays a major role. Okay, so if any vertex have a high degree nodes, okay, so that vertex the influence the entire community. Okay, so that's why, so we need to check who is the highest dominant on the data set. Okay, so that we can choose this. Okay, so for example, here we can check the I think if I type in every line, so that may take some times. Okay, so I can copy from my data set. Okay, so I can explain the each line by line. If I type every lines individually, that may take some times, I think so. Okay, so just we have created. Okay, so this is the this is, it will be helpful to find the high degree nodes. Okay, so the high degree nodes. Okay, so just we can use this a degree. The degrees are name. Okay, so this the dict is nothing but that is a dictionary of our data. So in this dictionary, so we need to collect the g dot degree. Okay, so the g dot degree of which will be, this is already we have done in the day one session, I think so. Okay, so the degree inbuilt function, the degree which will be collect all the vertex degree. Okay, so with the degree set, so we need to select the highest degree. Okay, so here we can have shorted. Okay, so this shorted function which will be create the arrange the degrees. Okay, so for example, in the range of 30. Also from the H. Okay, so H is nothing but that is a R subgraph. Okay, so from the top nodes. Okay, so this top nodes which we have sorted from the first 30 highest degrees. Okay, so just we select the sorted from the highest degree to the lowest degree. From this chart, we need to select first 30 highest degrees. Okay, so then easily we can attain the connected graph. In the previous one, you can see that is a disconnected one. Okay, so that we implement this. Okay, so here also we can fix the figure size and we can plot the graph. Okay, so just you can execute this. Now you can see. So this is the 30 vertex have a highest degree. Okay, so I think here the 4 vertex have remaining. Okay, so that here we can change it as a instead of a 20, 30, just I can choose the 25. So okay, so as per the data set, we can use this 30. Okay, so these nodes have the higher influence of the given data. Okay, so these are all the high top influential nodes. Okay, so these nodes plays a major role in the data set. Yeah, I have posted in the chat box. Is there any queries on this? Just we can plot the graph for the high influence degree. Yeah, Renuka ma'am, it's a wonderful question. Okay, if you are doing a so here we can select the samples. Okay, so that's why we can have some isolated vertices are there. But so these degrees, these vertex have the highest potential to highest potential for the remaining vertices. Okay, so here we have collected only the highest degree. Okay, so for example, it may have a star. Okay, so the N0127 have a star. Okay, so within the star, so that particular vertex have only the highest degree. The remaining have the lowest degree. The that is folks. The folks have a lowest degree. Okay, so that's why we can have some isolated vertices are there. Okay, so if it is in the social media or data analytics, so if the particular person have a highest degree, so he have connected with all the influencers. So that's why I say that is a very that plays a major role anywhere. Is this clear, ma'am? Shall we move? Yeah. Okay. So the next one, so we need to identify the community visualization. Okay. So we need to check the communities. Okay, so what are all the communities we have? Okay, so with the help of algorithm, okay, so that is a community, that is a greedy modularity communities is one of the algorithm we have. So which we'll use this greedy modularity communities algorithm, we can check the different communities within the data set. Okay, so the community is nothing but that is a group of nodes that have a community. Okay, so just wait, I can explain that. Okay, so this is for just we can apply this network X algorithms in the community. Okay, so this is a sub package. From this sub package, I can import this greedy modularity communities. Okay, so this is one of the algorithm which are available in the Python. Just we can directly collect this and find the different communities which are available in the data set. Okay, so here. Okay, so this is our, so totally 7 communities are available in this data set. Okay, so totally we have the 7 communities which are available in the data set. Oh, sorry, I think the previous code I didn't share. Yeah, I have posted. This one for the communities. Is this clear? If it is clear, we'll move on to the next. Shall we move?
Yes, sir.
Yeah. So as we identify that the 7 communities are there. Okay, so we need to visualize all the communities the one by one. Okay, so that is the next step. Okay, so that is a very simple tricks we have used to display all the communities. Okay, so for example, in the previous code, it's like just we can select the community. Okay, so first we select the 0 as our community. Okay, so which will be a subgraph. Okay, so G dot subgraph is nothing but that is a community graph. Okay, so with the help of this community, that will plays a major role in the community 1. Okay, so this is the graph we have the community 1. Okay, so this is a community 1. Okay, so in the similar way, we can check the 7 communities. Okay, so for example, if you want to check the second community, so we need to change it as a 1, and here we need to replace it as a 2. Okay, so now the community which will be increased. Okay, so just we can change the color. That is a green. Okay, so this is for the second community. Okay, so it's like that. We can check the all the topmost 7 communities. Is this clear? Okay, so suppose if you want to check the third community. Okay, so we need to change it as a 2. Okay, so here we need to change it as a 3. Okay, so just I can change the color, so blue. This is for our third community. This is our third community. Yeah, excellent, excellent. Exactly, man. Is this clear? So this is how we can visualize the communities. Okay. So totally we can in the data set have the 7 communities. Within the 7 communities, just we can visualize this one by one the what are all the community. If you want, you can visualize it. Is this clear? Shall we move? Yeah. So next, as of now, we had seen the first. We had seen sample graph and visualization techniques. Yeah, communities. Top influencing nodes. Yeah. Okay. So yeah, can I take 4 more minutes? Okay, so we can wind up exactly at 7:45. If you leave here, okay, so we can't continue on the tomorrow session. Okay, so that will be in intermediate. Okay, so just we can complete this part, the visualization. Okay, so the next part, suppose if you want to check the shortest path from the particular community. Okay, so for example, I want to check the here around we can have the 1200 nodes are there. So in this 1200 nodes, if you want to check the shortest path, okay, so just I can post the code. Okay, so with find the shortest path of for example, let me choose the vertex 1 to 100. Okay, so I want to choose the vertex n01 to n0100. Okay, so just find the um, mm, shortest path. Okay, so my source is n001 and the target is n0100. That is 100. Okay, so just we can visualize it. The remaining everything is same. That is already we had done. Okay, so this is for sorry. So this is for the shortest path. Oh, this data contain only 3. The distance, sorry, only the distance is 2. So n001 to n 0000. Okay, that is the only distance is 2. Okay, so we can change with the different vertices, different nodes. Instead of 100, just they can change it as 10. It's just we can check it.
Excuse
We
me,
can
sir.
choose N304. Yeah. Yes, sir.
Sir, will these be unique or there would be other 2 length paths also between these limits?
Yeah, totally we have 1200 nodes are there, sir, in the list.
Yes, sir, but this between the source and target we mentioned, we are getting an output.
Yeah.
So will this be a unique 3 length shortest path or there will be other paths also of length 3?
So unique path, sir. That's a unique path. 104. That is a shortest path.
Okay, sir.
Yeah. For example, here, just we select for the N001 to N034. Okay, so that is the shortest path which are available in N002, N303, and N304. That's how we have a shortest. The diameter is 3.
Okay, sir. Thanks.
Okay, so this how we can check the shortest distance. Okay, so from the particular target vertex to as a source vertex to target vertex. Okay, so remaining we'll see on the tomorrow session. Is this clear? Uh, I hope this will be get new experience for the new participants for this workshop. Okay, so even though if you are studied Python, if you are analyzed some networks, okay, so here we have work in the large data set. Okay, so it's around 1,200 vertices, 5,000 plus edges. Okay, so this will give some insights from the large data sets. Okay, so beyond the theory, okay, so we can apply here. We don't have a time to explain one more concepts. Okay, so how ChatGPT use the graph theoretical algorithms to choose the solutions. Okay, so that is one of the interesting area. Okay, so that's really wonderful. I have teached many places. Okay, so that is one of the interesting one. Okay, so how ChatGPT works behind our graph theory, how perplexity works behind our graph theory, how the data representations are working, how that shortest path which will be located from the particular keywords to a particular target. Okay, so that is one of the interesting area. So if possible, we can cover in this workshop. Okay, so this how in the large data sets we can apply the concepts. Okay, so is there any queries from the participant side? If you don't have a query, so please you can wind up. Okay, so suppose if you have any queries, so please we can discuss with 3 more minutes and we can wind up the session. And tomorrow we'll see the remaining tools.
Sir, as I told that I'm using in Jupyter, you told that you will explain at the end of the session.
Yes, ma'am. Okay, so can I share the WhatsApp group? Okay, so that is very simple. Okay, so you need to place the particular file in the same folder. Okay, so within the same folder, just right click the particular folder, copy the path. Okay, so then you can place it to your Jupyter file. That is
Sir,
very simple.
after downloading the file, what is the procedure? Can you
Just copy the
explain that?
file. Just copy the file. Go to the Jupyter Notebook folder. Okay, so for example, if you save the particular Jupyter Notebook into the different folder, for example, in the desktop, if you have saved the particular file, that is a Jupyter Notebook file.
Yes, sir.
So go to that folder,
Yes, sir.
open the folder, just paste in the particular file. That is a data file.
Yes, sir.
Yeah, just right click the particular file, the data file.
Sir.
Yeah. Copy as a path.
Okay.
Then go to the Jupyter Notebook.
Yes.
Just paste the path. That's it. Okay. So and we need to specify the sheet number that is available in the code. You can try that. Yeah,
Everything
Domini.
is okay, but I got that notebooks/network science book. So whenever I copy the path, it will automatically come in that notebooks/network Science 1000 node data set pack 1.
Okay.
Mm.
Just copy and paste it to the Jupyter notebook. That is a file path.
Yes, I have done, sir.
Yeah, if possible, I can help with in the offline, ma'am. Okay, so just
Sure,
share
sir.
the
Sure, sir. Thank you.
share share the WhatsApp. This is my WhatsApp number. You can share the screenshot. I can explain that. Okay, so this is my WhatsApp number. I have posted in the chat box.
Yes, sir.
Sir,
Yeah. Yes, ma'am.
sir, instead of Excel sheet, we may insert a graph structure to find the shortest path.
Graph structure. The JPG or PNG format, that's not readed, ma'am, in the Python.
Okay, sir. Which kind of Excel sheet only acceptable for this Python, sir?
Yeah. If you have a matrix format, okay, so for example, the particular graph in the matrix. Okay, so
Okay,
if
sir.
it is an adjacency matrix or incident matrix or distance matrix, any form of a matrix, easily we can upload, we can construct a graph. That is possible.
Okay, sir.
But we can't import the particular image and we can't do this type of operations.
Okay, sir.
Yeah.
Okay. Thank you, sir.
Thank you. Yeah, thank you so much for your active participation. Okay, so on the tomorrow, yeah, sure, sir. Okay, so in the latex part, we have an wonderful tools which we have developed by Infinity Research and Development Institute. That a single tool which will be helpful for all the graph theoretical aspects. Okay, so I can explain in the later. Okay, so tomorrow we move on to Surge Math. Thank you all for our active participation. Thank you so much.